to Educate Foundation YouTube channel. Today we want to look at a question. So in this question, we have several components put together. So here we are going to look at water balance and the Thiessen method put together in one question. So let's look at it. Before that, if you haven't subscribed, if you haven't subscribed to the channel, make sure you do that and make sure you turn on the notification. Also, earlier videos on the Thiessen method and the water balance method have been added to the description below, or you can look at it from the top at the end of the lesson. Now let's go into the question. Now the figure 2 shows the distribution of 5 rain gauges in and around the Wiwi Basin in Kumasi. The monthly rainfall for March 2024 recorded from the rain gauges P1, P2, P3, P4, and P5 are 81, 84, 87, 85, and 88 millimeters respectively. Also, the Thiessen Polygon area A1, A2, A3, A4, and A5 corresponding to the gauges are 20, 30, 74, 45, and 43 kilometers squared respectively. In the same month, monthly evaporation of 300 millimeters was recorded, and there was a net groundwater flow out into the basin was 10 meter cube per second. If the runoff coefficient of the basin is 0.68 and there was no surface inflow into the basin, estimate the basin's March 2024 A mean rainfall using the Thiessen method, B runoff, surface runoff, and C change in water storage. So we have several questions put together as one, and we are going. So the first thing that we are supposed to look at is to find the mean rainfall. So let's take the gauges. Let's write the parameters. The rainfall and their areas. So gauge A1, A2, A3, A4, A5. The rainfall they recorded were, so A1 is 81, 84, 87, 85, and 88. Areas we have 20, 30, 74, 45, and 43. Now this area, the unit is in millimeters. Sorry, the rainfall is in millimeters. The area is in kilometers squared, right? Now we are using the Thiessen. So the mean rainfall, according to the Thiessen, is equal to the sum of the individual rainfall times their area over their total area, right? So this is the formula that we are supposed. So we need the products of the individual rainfall and the areas. So the products. So let's find. So I have 81. So I just find the product of these. So 81 by 20 is 1620. 84 by 30 is 2520. 87 by 74 is 6438. 85 by 45 is 3825. And 88 by 43 is 3784. Someone will ask, why didn't we change the kilometers? We didn't make the area and the rainfall amount have the same meaning. Because we are going to divide by the area, there's no need for us to change the units, right? So we just leave it like that. So then what do we need? We need the sum of what? This. So I'm going to sum this whole thing, these whole values, and I'll get a sum. So when I sum them, that's 1620 plus 2520 plus 6438 plus 3825 plus 3 plus 37 plus 3784. And that will give us what? 18187. let me write it. 18187, and the unit here is in kilometers square. It's not a very nice unit to write, but let's leave it like that. Then we find the total area. So what do? I add these whole areas and I get the total area. So the total area is from 20 plus 30 plus 74 plus 45 plus 43, and that will give us 212 kilometers squared. So then my mean rainfall, which by the Thiessen method is this, is going to be 18187 over 212, and that will give us 85.78 millimeters. So this is the amount of rainfall. Have you gotten that? So let me write it here. Let me change the color. Write the amount of rainfall here. So the amount of rainfall is 85.78 millimeters. Have you gotten that? Now the next question is asking us to find what? The surface runoff. Now, what is surface runoff? So let me come here, B. So surface runoff is given by the equation C times E times R, where C is equal to the coefficient of the basin, A is equal to area of basin, and R is the mean rainfall. So that's how we find the surface runoff. So C is given the question as 0.68. We know the area to be 212 kilometers squared, and we know the mean rainfall to be 85.78 millimeters. Right now, with these ones, we need to change them to the same unit. So this is 212 times 10 to the power 6 meter squared, and this is 85.78 times 10 to the power minus 3 meters. Now we are changing them to the same unit, meters, right? So we can then find our surface runoff. So surface runoff is equal to 0.68 times 212 by 10 to the power 6 times what? 85.78 by 10 to the power negative 3. And so our surface runoff is, so it's equal to 12366,044.8 meter cube. This is the surface runoff. So let's keep it somewhere. So the surface runoff. So we have the mean rainfall to be 85.78 millimeters. Surface runoff, we had 12366,044.8 meter cube. Now the next question is asking us to find the change in water storage. So this is where the water balance equation comes into it. So we know that change in storage is equal to the in minus what? The out. But this time around, it's mostly we do it in terms of depth. But this one is in terms of what? Volume, right? So let's take the parameters. So the thing that we need in the question, the thing that was given. So let's see the thing that was given in the question. So they gave us, first of all, we've gotten the precipitation. So the rainfall is the precipitation. So we need volume of precipitation, that is in, right? Then we've gotten volume of runoff. So that one is out. So surface runoff, we've gotten it, it is an out. Now what is also giving? Monthly evaporation, but we need the volume of evaporation. That is also what? That is an out. Then they gave us the discharge of groundwater flow. We need the volume of groundwater flow. That will be an what? An in. So these are the things that are needed to go about our whole thing. So we need volume of precipitation, then volume of groundwater flow minus what? Surface runoff minus volume of evaporation. Now they did not, so first of all, we can find volume of precipitation, that is the volume of rainfall. Now we know the depth of rainfall, we can multiply the depth of rainfall to the basin. So the depth of rainfall times area of basin, right? So we have 85.78 millimeters, and the area of the basin is what? 212 kilometers squared. We cannot leave them like this, so we have to change them to the same unit. So 85.78 times 10 to the power negative 3 times 212 times 10 to the power 6, and that will give us what? This. So that one will give us what? 18185.360 meter cube. So this is the volume of precipitation. Let's find the volume of evaporation. Now they give us the depth of evaporation, then we just multiply by the area of basin. So the depth of evaporation, the evaporation was 300 millimeters, right? So the volume of evaporation, this is what I'm calling the depth of evaporation. So that is 300 millimeters times the area, 212 kilometers squared. And so if I'm changing the units, I'm going to get 300 by 10 to the power negative 3 meters times 212 times 10 to the power 6 meter squared, right? Milli is 10 to the power negative 3. Kilo is 10 to the power 3 by a square, that's why it's 6. So here, the volume of evaporation is equal to, so we are going to get the volume of evaporation to be 63600,000 meter cube, right? All right. Then the next thing left is what? Is so they gave us the discharge of groundwater to be 10 meter cube per second, but we need the volume of our groundwater. So volume of groundwater is equal to discharge times the time, right? So the discharge times time. Now we are in the month of March. So 30 days are September, April, June, and November. So the rest are 31. So this has 31 days. 31 days. 31 days. So we need it in seconds. So times 24 hours times what? 3,600. So we want the total time within the whole month of March is 31 times 24 times what? 3,600. And that time will be multiplied to the discharge to give us the volume. So the volume of groundwater will be equal to the discharge times the time. So that discharge is for 10 meter cube per second times the time, 31 by 24 by 3,600 seconds. So the second will cancel the second. So the volume of groundwater will be what? Let's multiply and see. So we are going to get 26784,000 meter cube. Now with these parameters, everything in place, we can put it in the water balance equation and find our stuff. So the water balance equation that we initially developed, the change in storage volume will be equal to volume of precipitation plus volume of groundwater, right, minus surface runoff minus volume of evaporation, right? So let's see. Volume of precipitation was 18185.3600 plus 360, sorry, 360 plus volume of groundwater. Volume of groundwater was 26784,000 minus volume of surface runoff. So we have surface runoff. Let's go and check. So surface runoff is 12366,044.8 minus then volume of evaporation, that is 63600,000. Now when you do the computation a change in storage in terms of volume will give us what? Okay, so putting a positive together, we are getting this, and putting the negative together, we are getting this. So this is the ins, and this is what the outs. Here we can finally find our change in storage in terms of volume. So we are going to get negative 30, sorry, 30996 684.8 meter cube. So the negative shows that there's going to be a decrease in volume of water in the basin. Yes, so we'll end here. Thank you very much for watching. And if you don't understand, because this is three major questions put together, you need to look up the water balance equation question and the Thiessen Polygon method in order to fully understand this whole question. Thank you for watching. Make sure to comment, like, and share this video. Educare Foundation, because we care. Bye bye.